Okay, hey there. So today we're going to learn about histograms and how to describe the shape of the data. So we've already figured out how to use numbers to describe where the center is and how spread out it is. But now we need some visual representations in order to figure out how the data is shaped, where clumps are, how to look at outliers. So we're going to learn about histograms. Now, I have some complicated instructions for you here that you can come back to maybe at a previous time, like take a screenshot. But of course this video is just going to show you how it works. Now, first of all, what is a histogram? What is a histogram? A way you can think about it is basically like a fancy bar graph, and I think you've all seen bar graphs before. It tells you how many things are in each category, and the taller the bar, the more things are in that category. So let's take a look at some data sets. First of all, our data set is relating to Taylor Swift songs. I looked on her most recent album as of May 2017, the album 1989, and I recorded the lengths of each song on the album. So here it is. Now what we could do is, again, we could figure out the mean, we could figure out the standard deviation, but I want to look to see how it is shaped. So what I'm going to do is I'm going to go into my calculator. And there are some complicated rules of making histograms on your own. I kind of like how the calculator does it, so I'll show you. We need to put this data in, so if you notice, if you hit Stat and then Edit, I already have the data preloaded in here in list 1, but obviously you need to enter that data in if you haven't yet. And now I'm going to have my calculator graph it for me. So don't go into y equals, go into second stat plot, the blue part of the y equals button. And let's hit plot 1. So first of all, you want to make sure plot 1 is on. If it's off, obviously just turn it on. Go down to type and you can select the bar graph because like I said, histogram is like a fancy bar graph. We want to make sure that the X list is describing the list that I want the data in, or that I have the data in, and my data is in list 1, so that looks good. And the frequency, just leave it as 1. You can hit enter. Okay, this is saved. If you hit zoom, oops, let's quit out of this. Okay, so here we go. If you hit zoom, and it's either 9, or if you hit zoom stat, that will zoom in to where the data is. And as you can see, I have a very nice histogram here. Now, I'm going to want you to be able to copy this onto a paper and label the axes appropriately. So first of all, let's draw a little first coordinate axis. And we're going to hit trace, and trace is going to show us some things. And I think you'll understand more what the histogram is doing when we see this. So if I hit trace, notice my little cursor thing is in the first column. And if I arrow right and left, I can go to different columns. And look at what information they give me. First of all, they give me the minimum, they give me the maximum, and then they give me an n number. So the minimum and the maximum relate to the x-axis. So the minimum here is 193, and it goes up to 208.4. If I arrow over to the next column, I see that its minimum is 208.4. And then its maximum is 223.8. And then if I go to the next column, its minimum is 223.8, and you get the picture. So if I just go to each column and look at the maximum and the minimum, I can see where my bar graphs should be. So let me just record these real quick. This is 270. And then the last one, its maximum is 285.4. So if you notice what's going on here, basically what a histogram does is it tells me, hey, how many of the songs are fitting in between each of these bounds. So let's go back over to the first column. This column has an n of 3. I'm just kind of labeling this y-axis, because if the n is 3, that means the bar is 3 high, which means there are 3 songs in between 193 and 208.4. So let's pick out those songs. Well, here's the 193 song that goes in there. Let's see, where else? Oh, here's a 195 song. That goes in there. And we need another song, 207. So these are the 3 songs that are between 193 and 208.4. The next column has an N of 4. And again, remember what that tells me. It tells me that there are 4 songs in between 208.4 and 223.8. Why the weird decimals? Well, that just, I don't know, is how they divided up the data. So let's just make sure we know what these songs are. I see a 212. That's in there. I see 211. That's in there. I see 220. That's in there. And I see, what else? 219. That's in there. So these are the 4 songs that are in that bar. And if you keep going, you'll see that there are 3 songs in the next kind of bounds. There are 2 songs in the next bounds. There are no songs that are in between 254 and 270. And then there is 1 song that's between 270 and 285.4. That would be obviously the maximum song, this one at 270. Okay, so this is the histogram. Now, every histogram you need a descriptive title and you need to label the axes. And if you know what you're doing, it should be obvious. For example, remember we said this is like how many songs are in each category. So this is the number of songs. The number of songs. Another thing that you could write is the frequency of songs. This is the number of times there is a song in that little category. Along the x-axis, what do these numbers represent? Well, what is the data here, right? Because this kind of relates to the data. And remember, the data is referring to lengths of songs in seconds. So I'll just put song length in seconds. So the x-axis here relates to song length in seconds. For the title, I'll just put length of songs in seconds from Taylor Swift's album 1989. Like, that'll be my title. I don't feel like rewriting it. You don't feel like watching me recopy it. So we're just going to call that the title. Your title should be very descriptive. It should tell about the units. It should tell about what the data is. Now, this is a really excellent histogram. This is what I'll want you to put on your project, but it should be neater and on a future quiz. Let's just real quick describe the shape of the data. The shape of the data, if I was to draw a curve, it kind of has its peak here and then it goes down, and there is maybe another little peak over here. But the point is, most of the data is over here to the left, and then the data kind of skews off to the right. Like, there is data over to the right, but it's much less frequent than to the left. We call this shape a skew right shape. And the reason it's skewing right is because, do you see how the data kind of has like a tail over here? Like, there is data and it's kind of trailing off, but the like hump or the concentration of data is over here to the left. So that's a skew right. Now, I'm going to take you through 2 more data sets really quickly. I'm not going to go as in detail about how to make the histogram. We're just going to look more specifically at the bar graphs. Maybe I'll talk about what you would label the axes, just to keep the video a little shorter. But this is your like golden example of how to do a histogram and how to use your graph for it. All right, let's look at the next group. This is ages of players on FC Barcelona, and I think this was for the season before last. Now, I have this data in list 2. So let's go back to stat plot. Remember the blue part of the Y button. We're just going to change plot 1 to list 2. So let's clear that out. List 2 is the blue part of the 2 button. So yeah, we'll hit second L2. Again, I need to zoom stat. Quit out of here. I need to zoom stat. So that's option 9. Let's look here. Okay, so this bar graph is very, very symmetrical. And if you notice, actually the middle couple bars are all the same, something like this. Now let's just talk about what the labels would be on the axis here. Because remember, if we trace, it's going to tell us how the bars should look. It's going to give us different information about the bars. Remember, the information along the x-axis, this is actually the like data. This is like the ages of players. But then on the y-axis, that's telling us how many players are in each category. So like how many players are in that category? How many players? So like if you look at this first bar that I have on my calculator, there are 2 players from the age of 20 to 22.16. Let's see if we can find them. Here's the 20-year-old, and here's the other 20-year-old. Those are the only 2 players that are from 20 to 22.16, okay? Now let's just real quick describe the shape of this data. If you think about where the hump is, it's definitely in the middle, and then it kind of trails off on either side. We would call this symmetrical, like it's symmetrical on either side. It's almost bell-shaped. The red line I drew is really well bell-shaped. Our data is a little too boxy to be actually bell-shaped, but if you know anything about the normal distribution, it follows this nice red curve. Our data isn't quite like that, but it's almost there. Okay, let's look at one more data set. Here are following scores from a recent Algebra 1 quiz. I have this data saved in L3, so let's just go back. L3 is the blue part of the 3 button. Quit out, zoom. Remember, you want to zoom to the stat. Okay, and here's my data. Now, the reason I chose quizzes is because most times quizzes are skew left, meaning most of the scores are good, because I kind of knew what I'm doing as a teacher, but then there's this group of people over here who just either didn't study or didn't pay attention, or maybe they're just not very good at math. So if I was to draw the distribution, I have like this situation. The hump is over here to the right. There's like a tail over here to the left. Like some of the data is over here, but it's kind of trailing off. We would call this skew left because there is some of the data to the left, but it's getting kind of spaced out. Most of the data is over to the right, so the skew is to the left. Let's just label the axes and then we'll be done. Remember, the y-axis is always like the number of things in each category. So in this example, it would be the number of scores. Like if we're looking at the first column here, there are 2 scores between 0 and 2.14. Here's one, and here's the other. Those are the 2 scores that would belong in this column. From 0 to 2.14. And then obviously the data on the x-axis is actually my data. This is like the score, and maybe you could put like out of 10. Usually my quizzes are out of 10, even though that information is not given in the problem. Okay, so histograms, extremely useful for seeing the shape. We discussed a symmetrical shape, we discussed a skew right, we discussed a skew left, and we discussed how to use the calculator to find the shape and give you a nice accurate histogram. Thank you for watching.